Right now, as you are watching this, the storm that just spent the last 2 weeks tearing across an entire ocean is finally dying out over the Yellow Sea. Before it got there, it engulfed the island of Rota so completely that satellite images show the entire landmass sitting inside its eye. It became, according to multiple reports, the most powerful tropical cyclone ever to strike a United States territory. It killed 18 people in the Philippines through landslides made worse by an earthquake that had struck the same region only weeks earlier. It nearly became the largest typhoon to hit Taiwan in more than 30 years. And then, in its final act, it slammed into eastern China, where authorities had already moved 2.8 million people out of its path and walked away with 0 confirmed deaths on the Chinese mainland. This is the story of Super Typhoon Bavi, the third Category 5 storm the planet has produced so far this year, and what scientists are now saying about why storms like this keep forming this way. No hype, no exaggeration, just what actually happened and what the data behind it means. Drop a comment and tell me if you or anyone you know was in the path of Bavi in Guam, the Marianas, the Philippines, Taiwan, Japan, or China. I read every one of these. If you want grounded storm coverage instead of panic headlines, subscribe. It is free. And a like helps this reach people who need to understand these storms before the next one forms. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. Bavi's story actually begins in the last days of June, when it first organized as a tropical depression in the Western Pacific. What happened next is the part meteorologists keep coming back to, because it is a genuinely textbook example of a phenomenon called rapid intensification, formally defined as an increase in maximum sustained winds of at least 30 knots, or about 35 miles per hour, within a 24-hour window. Bavi did not just meet that threshold, it blew past it by mooring, then double. According to the Joint Typhoon Warning Center, Bavi's 1-minute sustained winds jumped from about 80 miles per hour at 6 in the evening on July 2nd to roughly 145 miles per hour by noon on July 3rd, a 75 mile per hour increase in a single day, taking it from tropical storm strength to a Category 4 equivalent typhoon in only about 18 hours. By 9 in the evening that same day, Bavi had already been upgraded again, this time to a Category 5 equivalent super typhoon. The conditions that allowed this kind of explosive strengthening were, in the words of meteorologists tracking it, close to textbook. Sea surface temperatures along its path sat at 29 to 30 degrees Celsius. Ocean heat content exceeded 110 kilojoules per square centimeter, meaning the warm water extended unusually deep below the surface, and wind shear, the disruptive change in wind speed and direction with altitude that normally tears a strengthening storm apart, measured only 5 to 10 knots, about as low as it gets. Warm water gave Bavi the fuel. Low wind shear gave it the freedom to actually use that fuel without being torn apart in the process. Bavi briefly wobbled through an eye wall replacement cycle on July 4th, a normal process where a storm's inner eye temporarily weakens as a new, larger eye forms around it. But by July 5th, it had re-intensified straight back to Category 5 strength. That is when Bavi made direct contact with United States territory. At 8:40 in the morning, local time on July 6th, the typhoon made what satellite imagery from the Himawari 9 satellite showed as a complete engulfment of the island of Rota in the northern Mariana Islands, the eye passing directly over it. Reporting following the event described Bavi as the most powerful tropical cyclone ever to strike United States territory. The National Weather Service had warned in the hours beforehand that the storm posed imminent danger to life across Guam and the Marianas. The Federal Emergency Management Agency stated it would move in to support Guam and the northern Mariana Islands as soon as the storm cleared the region. From there, Bavi turned northwest, weakening only gradually as it crossed open ocean still warm enough to sustain it, and by July 9th, it brushed the southern islands of Japan's Okinawa Prefecture. More than 200 flights were canceled across the region, thousands of households lost power, particularly in the Miyako area, and 82,939 people were evacuated across Okinawa Prefecture, with 12 minor injuries reported. At the same time, forecasters in Taiwan were watching a genuinely alarming trajectory. On Friday, July 10th, Bavi had been on track to become the largest typhoon to strike Taiwan in more than 30 years. The storm's wind field ultimately shrank before arrival, with its strong wind radius contracting to about 350 kilometers, and Bavi ultimately skirted past Taiwan's north rather than making direct landfall. Even so, the island shut down almost entirely. Taiwan's Central Weather Administration warned of extremely torrential rain and dangerous waves up to 10 meters along the coast. More than 14,000 people were evacuated, mostly from mountainous areas in the north and east. Taiwan's main international airport at Taoyuan effectively closed, with more than 900 international flights and dozens of domestic flights canceled. Taiwan's fire department reported 134 injuries. the overwhelming majority from people falling off motorcycles and bicycles on rain-slicked roads, or being struck by wind-blown debris, rather than from direct structural collapse. More than 170,000 households lost power. Before Bavi ever reached Taiwan or China, it had already amplified a separate, deadlier disaster far to the south. In early June, a magnitude 7.8 earthquake had struck Mindanao in the southern Philippines, fracturing and saturating hillside soils across the region, weakening their structural cohesion without anyone necessarily realizing how much. When Bavi's outer rain bands intensified the seasonal monsoon and dumped heavy rain across that same region before dawn on July 10th, those already destabilized slopes gave way. A landslide swept through the village of Sitio Fandao in Malapatan in Sarangani province, killing 10 people. A separate landslide in Calanogas in Lanao del Sur province killed 6 more people and left several others missing. 2 additional people drowned in floodwaters in Bukidnon. The regional civil defense director told reporters that victims were buried when soil, already saturated by days of rain, simply collapsed. The Philippines Office of Civil Defense ultimately reported 18 confirmed deaths, all from landslides and flooding tied to monsoon amplification rather than a direct hit from the typhoon itself, and declared a state of calamity in Calanogas. Nearly 11,000 people fled their homes across the archipelago, and more than 562,000 people were affected in some way. Then came Bavi's final act, the landfall the title of this video refers to. By the time Bavi reached China, the same eye wall replacement. Cycles, increasing wind shear, and progressively cooler sea surface temperatures along its northward track had worn it down considerably. It made its first landfall near Yuhuan on the coast of Zhejiang province at around 11:20 at night local time on July 11th, with maximum sustained winds of about 144 kilometers per hour, roughly 90 miles per hour, equivalent to a Category 1 storm on the Saffir-Simpson scale used for Atlantic hurricanes. A second landfall followed shortly after midnight in Yueqing, a district of the densely populated city of Wenzhou. Even weakened to that level, Bavi still felled more than 1,300 trees in Yueqing alone, with roughly half of them torn out by the root, according to state broadcaster CCTV. A resident in Yueqing described hearing roof tiles and tree branches falling throughout the night, and said a walkway beside his housing compound had simply disappeared underwater. But the story of Bavi's final strike in China is really a story about what Chinese authorities did in the days before it arrived. And this is worth sitting with, because it produced one of the more remarkable outcomes of this entire event. China's state flood control and drought relief headquarters raised its emergency response level for Zhejiang and Fujian well before landfall. Coastal regions were ordered to recall fishing vessels to port, and evacuate offshore platform workers, and reinforce infrastructure. In total, Chinese authorities moved approximately 2.8 million people out of Bavi's path, roughly 2.2 million from Zhejiang province alone, with more than 100,000 additional evacuations in Fujian, 34,000 in Shanghai, and thousands more in Ningde. Even inland, more than 100,000 people were evacuated from Beijing as authorities ramped up water discharge from the capital's Miyun reservoir to get ahead of potential flooding, despite Beijing sitting well outside the storm's direct path. As of the most recent reporting, that evacuation of 2.8 million people had produced 0 confirmed deaths on the Chinese mainland. Compare that. Outcome to the 18 deaths in the Philippines, all from landslides that struck communities with essentially no equivalent lead time or evacuation infrastructure once the earthquake weakened soil met the amplified monsoon rain, and you get a genuinely important lesson buried inside this storm's path. The same system that killed nobody directly in one country killed 18 people in another, and the difference again comes down overwhelmingly to preparation, warning systems, and how much lead time authorities gave residents to actually leave. It is also worth understanding that Bavi did not strike at China that was otherwise having a quiet summer. It was actually the second typhoon to hit the country within just over a week. Tropical storm Maysak had already made landfall in southern China on July the 3rd, and flooding tied to that earlier storm alone had already killed at least 39 people and caused dozens of rivers to swell before Bavi ever arrived. That back-to-back sequencing matters because it meant emergency responders, drainage systems, and already saturated soils across parts of southern and eastern China were dealing with Bavi's rainfall on top of ground that had barely had time to recover from the previous storm, which is part of why authorities treated the flood risk from Bavi's rain bands, described by meteorologists as roughly the size of France from end to end, as seriously as they did even after the storm itself had weakened well below its peak intensity. Now let us talk about what scientists are actually saying about why storms like Bavi keep forming this way, because this is the part that matters for understanding what comes next, not just this one storm. Bavi is officially the third Category 5 equivalent tropical cyclone the planet has produced so far this year. The first was Tropical Cyclone Horatio, which reached 160-mile-per-hour winds over the remote southern Indian Ocean back in February, though it never made landfall anywhere. The second was Typhoon Sinlaku, which tracked just southeast of Guam in mid-April with winds reported around 185 miles per hour at its peak, becoming the strongest tropical cyclone anywhere on the planet so far this year at that point, and killing 17 people while causing about $1.5 billion in damage to the northern Mariana Islands and Guam. Meteorologist and former NOAA hurricane hunter Jeff Masters noted that Sinlaku was, remarkably, the 10th Category 4 or 5 tropical cyclone to strike a United States state or territory in just the past 10 years, which is as many Category 4 and 5 landfalls as the United States endured across the entire prior 57 years combined. Bobby joining that list within the same year is not something climate scientists are describing as a coincidence. The underlying scientific concept here is called maximum potential intensity, a theory pioneered back in 1987 by MIT hurricane scientist Kerry Emanuel. Maximum potential intensity describes the theoretical ceiling on how strong a tropical cyclone can become, based entirely on the ocean and atmospheric conditions it is moving through at that moment. Emanuel's foundational insight, one that has held up across decades of subsequent research, is that human-caused global warming raises that ceiling, meaning the maximum strength any given tropical cyclone is physically capable of reaching, keeps climbing as the oceans absorb more heat. This does not mean every storm will hit that ceiling. Wind shear, dry air, and other atmospheric breaks still routinely prevent storms from reaching their theoretical maximum. But it does mean that when the other ingredients do line up favorably, the way they did for Bobby in early July, the physical ceiling on how strong that storm can get has moved measurably higher than it would have been decades ago. There's also a broader seasonal context driving this, worth explaining honestly rather than glossing over. NOAA officially declared that an El Niño event was underway on June 11th of this year and immediately flagged the possibility that it could grow into one of the strongest El Niño events on record, with some models suggesting a potential peak in December that could rival or even exceed the historic 1997-98 Super El Niño, one of the most extreme such events ever recorded. El Niño years tend to reshape ocean heat distribution and wind patterns across the Pacific in ways that can make conditions like the ones Bobby encountered, warm surface water, deep ocean heat content, and low wind shear considerably more common. That is part of why meteorologists were describing this year's setup as textbook for a strengthening El Niño year specifically, rather than describing Bobby as some kind of freak, one-off anomaly. There's also a broader ocean warming backdrop behind all of this worth mentioning, since it explains why conditions like the ones Bobby encountered are becoming easier to find rather than harder. The European Union's Copernicus Marine Service reported just last week that the world's oceans had just experienced their hottest June on record, and warned that fresh highs could still be set in the months ahead as the year continues. A warmer global ocean does not guarantee that any specific storm will intensify rapidly, since wind shear, dry air intrusion, and a storm's own internal structure all still play a role in whether a system actually takes advantage of the warm water beneath it. But it does mean that the baseline pool of ocean heat available for a storm like Bobby to draw from, should the other ingredients line up, keeps getting larger year over year, which is precisely the trend maximum potential intensity theory predicted decades before anyone was watching Bobby specifically. So, what does all of this actually mean for you? If you live anywhere in the Western Pacific Typhoon Basin, the practical lesson from Bobby is not that every storm will reach Category 5 strength. Most will not. The lesson is that the conditions capable of producing that kind of explosive, unpredictable strengthening are becoming more common in a warming ocean, which means storms deserve serious attention earlier in their life cycle, well before they reach their eventual peak intensity, rather than waiting to see what category they officially reach before taking preparation seriously. China's response to Bobby, moving 2.8 million people well ahead of landfall and producing 0 mainland deaths, stands as close to a real world demonstration of what that kind of early decisive preparation can accomplish, even against a storm that had been a Category 5 monster just days earlier. The outcome in the Philippines, where an already vulnerable earthquake-weakened landscape met an amplified monsoon with far less warning infrastructure in place, stands as the counterexample. The honest, grounded summary is this: Bobby intensified from a tropical depression to a Category 5 super typhoon in a matter of days, driven by textbook rapid intensification conditions that scientists increasingly link to a warming ocean and to a developing El Niño event that could become one of the strongest on record. It became the most powerful tropical cyclone ever to strike United States territory when it engulfed Rota, compounded an earthquake-weakened landslide disaster in the Philippines that killed 18 people, nearly became Taiwan's largest storm in 3 decades, and then made its final landfall in China as a weakened Category 1 equivalent system, where advance evacuation of nearly 3 million people produced 0 confirmed mainland deaths. It is now the 3rd category, 5 storm of a year, that is only a little more than half over, following Horatio in February and Sinlaku in April, in a season scientists are watching closely precisely because the ingredients behind storms like this keep showing up in the data. We are going to keep tracking this as the rest of typhoon season develops, sourced the same way we did today, straight from the Joint Typhoon Warning Center, and NOAA, and the meteorologists actually studying these systems, not recycled headlines. Subscribe so you do not miss the next one forming, because based on what we just walked through, it likely will not take long. And leave that comment below. Tell me where you're watching from, and whether a storm like this has ever come close to you. Because behind every one of these numbers is a family in Zhejiang taping their windows, a resident in Sarangani who lost everything to a landslide nobody could have stopped once the ground gave way, and an 82,000 person evacuation in Okinawa that most of the world never even heard about. 5,000 likes on this one. Let us go. See you in the next one.